paper 5, S1, and this is the first variant that we are trying out. Let's look at the first question. The first question is, a bag contains 12 marbles, each of a different size. 8 marbles are red and 4 of the marbles are blue. So there are 8 red marbles and 4 blue marbles. So this is 8 and this is 4. 8 and 4. How many different selections? That means it's a question of combination. NCR. So this is about combination. How many different selections of 5 marbles contain at least 4 marbles of the same color? So now if it says at least 4 marbles, that means exactly 4 or exactly 5, because up till 5 is possible. Let's see how it's possible. If I draw this line, and let me draw few more lines. The first scenario is, there are 4 red and 1 blue. This is a possibility. This is exactly 4. It could be 4 over here and 1 over here. That adds up to 5. It could be 5 and 0. Can it be 0 and 5? So can this be 0 and this be 5? The last one is not possible. This is practically not possible, because how can you select 5 out of 4? So the answer for the first part, let me just take it down. The answer for the first part is 8C4 multiplied with 4C1. And then the answer for the second part is 8C1 into 4C4. This was simple. This is 8. The answer for this part, 8C5 into 4C0, and this comes out to be 56. The first one, 8C4 into 4C1, comes out to be 280. So you add it all up, and this answer comes out to be 344. So that is the working for the first question for 4 marks. Second question. Let me highlight the name. A company produces particular type of metal rod. The length of these rods are normally distributed. So this is normal distribution, with mean such and standard deviation such. So therefore X follows normal distribution, 25.2 and 0.4 square. A random sample of 500 of these rods is chosen. Why have they given this number? Let's see. How many rods in this sample? So they are asking how many. This is basically the expected value that they ask. So this question is about normal distribution as well as the expectation formula from binomial, which is NP. So this is binomial. Why it is binomial? Let me explain you in very shortly. How many rods in the sample would you expect to have a length? Here is the word expect, to have a length which is within 0.5 centimeter of the mean length. Now let me insert a normal distribution graph over here. And if I say this is the mean, irrespective of the value of the mean, so this is mu, and it is within 0.5 centimeter of the mean. So therefore somewhere here is 0.5 centimeter. So therefore this is mu plus 0.5, and over here again it's mu minus 0.5. So this is mu minus 0.5. This one is this one is this. Now it doesn't make a difference whether I use the actual value or not. For example, if this is 25.2, I add 0.5, what do I get? 25.7. And if I subtract 0.5, what do I get? 24.7. Now we can work with any one of them. It says probability X lies between 25.7 and 24.7. Probability Z lies between 25.7 minus 25.2 divided by square root of, actually standard deviation is already given as 0.4. And over here, let me create further space. So therefore, this is 24.7 minus 25.2 divided by 0.4. And over here is your Z. So therefore, this is Z lying between these two. When you do the subtraction, this comes out to be negative 0.5. When you do the subtraction, this comes out to be positive 0.5. The same scenario would have been obtained if I would have written probability X lies between mu plus 0.5 and this is mu minus 0.5. Probability Z lies between mu plus 0.5 minus mu divided by sigma. And this is mu minus 0.5 minus mu divided by sigma. What is the value of sigma? In this scenario, it is 0.4. Probability Z lies between what goes at the top, 0.5 divided by 0.4. Over here, what goes at the top, negative 0.5 and then divide by 0.4. So this working is exactly the same thing as this working. So whether you use the value or not, it doesn't make a difference. And what is the region that you are interested in? We are interested in this particular region, the probability for this. So that's how we would be doing the calculation. Let me erase the extra stuff like this. So now we would do the calculation. Probability Z lies between 0.5 divided by 0.4, that is 1.25, and then the other one is also negative 1.25. So this is rule number 7. Phi of 1.25 plus phi of 1.25 minus 1, and then you get the final answer, which in this scenario comes out to be 0.7888. Now let's introduce binomial over here. So first of all, let me arrange this in a box. This is separate. And over here, we are introducing binomial. So therefore, X follows or Y follows a binomial distribution. 500, 0.7888 is the probability of success. And they are not asking for probability, they are asking for expectation. So expectation of Y is NP, that is 500 multiplied with 0.7888. So the answer is coming out to be, after rounding off, first of all, let me multiply. So when I multiply, that is 0.7888 multiplied by 500, this comes out to be 394.4. Both answers are acceptable because you're not going to break a rod. 394 is also acceptable, 395 is also acceptable, because the rods has to be in integer. The answer has to be in integer. So that is the working for question number 2. Let's move to question number 3. Now question number 3 is about, let me underline it. It's about arrangement. It's about arrangement and it's about arrangement. So this is totally about arrangement. So that's how it is. So this is NPR, permutation, arrangement. 8 letters of the word released. R, E, L, E, A, S, E, and D. So what do you have? You have these 3 E's, and then you have 1, 2, 3, 4, 5. Answer for the first part is 8 factorial divided by 3 factorial. That is answer for 1 mark. How many different arrangements are there of the 8 letters of the word released, in which the letters LED, first of all write this, LED appear together in that order. That means LED should be in a box. So let's put it in a box. And this is L, E, and D. And what are you left with? You are left with R, L, A, S, that is 4. And then you have R, L, A, S and a double E. So that is 6 and the box is together. So how many arrangements are there? How many words are there? R, L, E, D. So therefore L is already used. So this is extra over here. Let me erase it and let me push it to the left. So therefore there are 5 alphabets. This is 1, 2, 3, 4, 5 and the box. This is 6 factorial. Then divided by 2 factorial for the ease. So divide by 2 factorial for the ease. What is happening inside the box? So now inside the box, what is happening? Inside the box, nothing is happening. Why? Because the order is fixed. LED is fixed. It's not changing. So it's just 1. So the answer is 6 factorial over 2 factorial. Now let's look at the other part, which is part C. What does it say? It says an arrangement of 8 letters of the word release is chosen at random. Find the probability. So this time they're asking for probability that the letters A and D are not together. So let me go to the first part, which is 8 factorial divided by 3 factorial, because this answer will be the denominator of part C. Using a calculator, this comes out to be 6720. So therefore, answer of part A, 6720, that is the denominator for this probability. A and D are not together. That means A and D are separated. So if I say A and D are separated, what do I have? I have R, E, L, E, A is separated, S and E and D. So now when we have this scenario, therefore we will write 1 and let me label it 1, 2, 3, 4, 5, 6, 7. This thing is about A and D not together. So this is 7p2 multiplied by. For the purple one, this is 6 factorial but divided by 2 factorial for the ease. So this will be your numerator and this numerator comes out to be 5040. Therefore, the probability would be 5040 divided by 6720 and then you can round it off. Let me show you the alternative way also. So the alternative way, that is actually, let me double check my working. So now this is 7p2 is 7 into 6. So I'm writing it on the side. 7 into 6, 6 factorial is 720 and divide by 2 factorial is 2. So therefore 720 into 7 into 3. I think there is a issue with the answer. This is A and D. So R, E, L, E, S, E. No, my bad. This is 3 factorial. So therefore, this is not 2 factorial. This is 3 factorial. So let me correct this thing. So this is 3 factorial for the e's. So therefore, there is an extra E which I missed out. This is 3 factorial. So therefore, 7 into 6, 6 factorial is 720. So therefore, 7 into 6 into 720 and then divided by 6, that's 5040. This is all good and all perfect. So this is 3 factorial and I have double checked it. Now, alternative way, that is first find A and D together. So if I put A and D together, that is AD is here. And what do I have? I have a triple E and I have RLS 1, 2, 3, 4, 5, 6 and 7. That is 7 factorial divided by 3 factorial, and what's happening inside the box? 2 factorial. So this is 5040 multiplied by 2 and then divided by 6. This comes out to be 1680. Without any restriction is answer of part A, that is 6720. Therefore, A and D not together is 6720 minus 1680. So 6720 minus 1680. This comes out to be 5040, and therefore the probability is 5040 divided by 6720, and that's the answer that you get. Let's move to another question. This time the question looks like a tree diagram. So this is a probability and it's a tree diagram question. The question says, to gain a place at a science college, students to gain a place, a seat at a science college, students first have to pass a written test and then a practical test. First is written, then it's practical. Each student is allowed a maximum of 2 attempts, max of 2 attempts at the written test. A student is only allowed a second attempt if they fail the first. Naturally, that's the case. So only second attempt if they fail the first. No student is allowed more than 1 attempt at the practical. So practical is only 1 attempt. If a student fails both attempts at the written test, they cannot attempt the practical test. That makes sense. Now it says, find the probability that the student will pass, and now the probabilities are given. Let me first start labeling it. So first of all, there should be a big line and then a small line. Why am I making it like this? Because this is passing on the first attempt, this is written test, this is pass, this is fail, and this is the first attempt. If they pass on the first attempt, they can reach the practical. So therefore, over here, when I talk about the practical exam, it's gonna be pass and fail. So this is practical test, and this one is pass, this one is fail, and there is only 1 attempt. If the person fails the written test, then he is given another chance. So therefore, again, like this is second attempt at the written test, and this is pass and this is fail. Make sense? And if a student passes the second attempt, he can give the practical. So that is like this and like this. So this is practical test, and this is pass, and this is fail. So that is the scenario for this one. Look at it very closely. This is a question like we did something with Peter, and there was a game show in which he can call his friend or ask from the audience. This question is something like that. The probability that the student will pass the written test on the first attempt is 0.8. So this is 0.8, this is 0.2. Fails the first and then pass the second attempt is 0.6. So this is 0.6, this is 0.4. Then the practical test, passing is always 0.3, whether it's on the first attempt or the second attempt. 0.3, 0.7, 0.3, 0.7. So that is the complete picture that you have. Find the probability that a randomly chosen student will succeed in gaining a place at the college. That means this scenario would be passing on the first attempt and then passing. So this scenario is there. It could be failing at the first attempt, passing at the second attempt, and then passing. So therefore, this is the second scenario. So this is 0.8 into 0.3. So this is 0.8 into 0.3, and the other option is 0.2 into 0.6 into 0.3. So use the calculator and multiply it out, and this, the answer that you get is, in the first part, is 0.276. So this comes out to be 0.276. That's the answer for this part. Third part, too much space is given because the tree diagram was already for 3 marks. Find the probability that the randomly chosen student passes the written test at the first attempt, given. So this is passing at the first attempt, given the student gains a place at the college. So basically, the answer for part C is this: 0.8 into 0.3 goes down, 0.2, 0.6, 0.3 goes at the bottom, which naturally is 0.276. And over here, this is passing written test on first attempt. This is passing written test on second attempt, which is the thing that is relevant for us. That is this thing. So 0.8 into 0.3, that goes at the top. So 0.240 goes at the top, and then you divide, and then you get this particular answer. Okay, so that finishes question number 4. Question number 5. This thing is about frequency distribution, histogram, mean, and something to do with the interquartile range. Now this thing over here that you see, this I have pasted it myself. It was not written in the original question, so I just have pasted it. So now the first thing is that this is frequency distribution, and it's about mean, and they did not ask standard deviation, is about histogram, and it's about something to do with the greatest least value of interquartile range. First of all, when we have to discuss about histogram, the very first thing that you should observe is that it's ending at 10, starting with 10, ending at 20, starting with 20, ending at 40, starting at 40, ending at 60, starting with 60. So therefore, the very first thing is it's already given as class boundaries. That's the first thing. Second thing, that is that in this scenario, is it class widths are equal or unequal? So second thing, class width is upper class boundary minus lower class boundary. Over here, the class width is 10, and this is 10, and this is 20, and this is 20, and this is 40. So this is unequal class width. Therefore, it's a concept of frequency density. So let me draw a vertical line like this, and then a horizontal line like this. So therefore, now the vertical axis is frequency density, and the horizontal axis are the class boundaries, which in this scenario is the time. So basically, it's time in seconds. And now I have to do some working. So let me do the working on the next page. So let me draw up a table. So this table is something, let me just make a box out of it. And this is class boundaries, and then frequency, and then class width, and then frequency density. So the class boundaries are 0 till 10, and 10 till 20, 20 till 40, 40 till 60, and 60 till 100. The frequencies are 16, 54, 78, 32, and 20. The class width is 10, and 10, and 20, and 20, and 40. Frequency density is frequency of a class divided by class width. That is the formula for this part. So now 16 divided by 10, that is obvious, 1.6. This is obvious, 5.5. 4, this is 3.9, and then 32 over 20, 1.6, 20 over 40, 0.5. So now the highest value is 5.4. So I'll just set it up like this. Therefore, this is frequency density 1.0, this is 2.0, this is 3.0, 4.0, then it's 5.0, and then this is 6.0. So that's the frequency density. And then it's 0 till 100. So this is 0, and this is 20, and this is 40, 60, 80, and 100. So that's how you do the labeling. And then you draw vertical bar. Let me just draw one bar, 0 to 10, that is the height of 1.6. So 0 to 10, that is the height of 1.6. So somewhere here is 1.6, and this is 10, and let me draw a thin one, and then you can see the enlarged version. So this is going up like this, like this, like this, up till here, and then like this, and then like this. So that is the first bar that I have drawn, and similarly you can draw the other bars. So frequency density over class width. A frequency density is class frequency over class width, and what goes there, what goes where, and so on. Now the second part, that is estimate of mean and variance. So that is straightforward because they have not asked a standard deviation. So therefore it's very simple. You don't have to draw that 5-column method. All you have to do is to locate the mid value, that's 5, 15, 30, 50, 80. X bar is sigma fx over sigma f, that is 5 into 16, 15 into 54, 30 into 78, plus 50 into 32, plus 80 into 20. Everything added together divided by the sum, that is 200, and then you get the answer. First 4SF, then 3SF. Now this part, find the greatest possible value of the interquartile range of these times. I'll go for the greatest, I'll also go for the least. So let me explain you both of them. 200 divided by 2 is 100, and 200 divided by 4 is 50, and 200 into 3/4 is 150. This is the value for median, this is the value for lower quartile, this is the value for upper quartile. This is not raw data, this is not a stem plot that you have raw data, this is a frequency distribution. So that's why you can only get a estimate out of it, and technically a range, a greatest possible value or the least possible value. So where is the 50th value? The first 16 are here. 16 plus 54 is 70. That means the 50th value lies in this range. So the 50th value, that is the lower quartile. So lower quartile is somewhere over here. Now add it up again. 16 plus 54, that is 70. 70 plus 78 is 148. Therefore, this one over here, that contains the upper quartile. So the upper quartile is somewhere over here. So now you are looking at two ranges. One range is 40 to 60. So 40 to 60 contains upper quartile, and 10 till 20 contains lower quartile. Now this is like an O-level math question of upper bound and lower bound. So this is lower bound, and this we are looking for upper bound. Now there are four values. There is the 60 and 10. So 60 is the highest value, minus 10, that comes out to be 50. That is the greatest value of interquartile range, because interquartile range is upper minus lower quartile. And when you choose this and this value, the lowest value of upper quartile, highest value of lower quartile, so 40 minus 20, that is 20, that is interquartile range, least value. So I have done more than what they have asked for, and just to explain to you this concept in full totality. Now question number 6. What is question number 6 all about? It looks like binomial to me, the first part. The second part, yes, it's binomial, and justify the approximation. So now this is binomial probability distribution. It says in a town, Cuesta, 60% of the adults travel to work by car. So that's 60%. A random sample of 12 adults. Probability, number who travel to work by car is less than 10. X follows binomial distribution 12, 0.60. Less than 10. Probability X is less than 10 does not include 10. Probability X is less than or equal to 9, which is too much to calculate. Therefore, this is 1 minus probability X is greater than or equal to 10. 1 minus, write every single detail. That is 12C10 and 12C11 and 12C12. Bracket closed. This is 0.6. This is 0.4, that is failure. And the power of success is 10. Power of success in this term is 11. Power of success in this term is 12. The difference, 12 and 10, is 2 and 1 and 0. That goes over here. Now you should write down everything over here like I'm writing. 1 minus. The 12C10 value is 0.063852. 0.063852. Next value, 0.017414. 0.017414. Next value, 0.002 21768. 0.00217, and then it's 68. And you can double check the result. So now then you write the final answer, which is 0.917. This is rounded off to 3 significant figure, and the examiner pays a lot of emphasis on this. That show every single piece of working. So show everything, every piece of working. Assume nothing. That this is obvious. Nothing is obvious. You have to make it obvious. Now, what does it say? A random sample of 150 adults. So now this is use an approximation. Find the probability travel to work by car is less than 81. First of all, X follows a binomial distribution 150, 0.6. N is 150. P is 0.6. Q is 0.4. First of all, NP 150 into 0.6, that is 90. NQ 150 into 0.4, that is 60. NP, I'm simply writing it again. And NPQ. So 9 4s are 36. I think this is 36. Do double check my working. So therefore, this is what you get. And it's asking for justification later. I'm doing the justification in the beginning, whether the examiner asks about it or not. This is the justification. Since NP is greater than 5 and NQ is greater than 5, this is for part C. In the exam, actually, you have to write it over there. Therefore, X follows a normal distribution 90, 36. And then it says lesser than this. X follows normal distribution 90, 36, and probability X is less than 81. Draw a quick number line. So this is a number line. This is 81. This is 81.5. This is 80.5. And let me double check. It's less than 81. So 81 is not included. So one number line is like this. Another number line is like this. Which one is the one relevant for us? It's 80.5. So therefore, after continuity correction, probability X less than 80.5. You are back to the basic. Z is less than 80.5 minus 90 divided by square root of 36, and then you get this answer. So now this thing is done. Justification already done. Now, what is this question all about? This question looks like a DRV question. Once you get hang of the table, then the variance is easy. The first part is for help. So this is the help that the examiner gives us. Not that I'm asking for it. So this is what the help the examiner gives us. So now the first thing is Sharma knows that she has 3 tins of carrots and 2 tins of peas and 2 tins of sweet corn. So there is 3 cans of carrots and 2 tins of peas and 2 tins of sweet corn. Let me write this thing as SW. And all the tins are of the same shape and size, but the labels have been removed, so Sharma does not know what each tin contains. Sharma wants carrots for her meal, and she starts opening the tin one at a time, chosen randomly, until she opens a tin of carrots. The random variable x is the number of tins that she needs to open. Now the word until might give you the sense that this is geometric probability distribution, but in geometric probability distribution the probabilities are fixed. Over here it's not fixed because this is a without replacement question. So first of all, this is a without replacement question. This is not geometric probability distribution. So this has to be done using the probability way. So we will use it using the probability method. Of course, we have to calculate the probability. Now, what if let me look at the complete picture. Draw up a probability distribution table for x. I'll be doing this, and naturally I'll get the answer for this one also in this method. Probability x equals to 1. You get lucky. Sharma gets lucky in the first instant. Probability x is equals to 2. Let me write everything. Probability x is equals to 3. There are 3 carrots and 4 others. That means if, let me first write it. Probability x is equals to 4 and probability x is equals to 5, and I'm stopping over here. Why? The 4 cans that she opened, the extreme could be the 2 are peas and the 2 are sweet corn. That means naturally the 5th one has to be carrot. So basically this will be categorized as 1. So 2 peas, 2 sweet corn, this is 4 others. And this is red for carrots. Okay. So now keep this in mind. So basically I have 3 cans of carrots. Is that the right spelling? CARR. Okay. And there is single T. So C and like this. 3 carrots and 4 others. So now the first denominator is simply 7. You're selecting out of 7 and it came out to be a carrot like this. So that is 3 over 7. That is the answer for the very first part. Probability x is equals to 2. So let me first write down all the denominators. So now this is 7 and this is 6. For 3, this is 7 and this is 6 and this is 5. For 4, let me create more space. So let me pull it down. Pull it even down like this. Okay. Now, probability x is equals to 1. That's 3 over 7. I'm first labeling the denominators. That's 7 into 6 into 5. And this is 7 into 4. And this is 7, 6, 5, 4, 3. 7, 6, 5, 4 and 3. Multiply, 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 multiply like this. And let me readjust it like this. Now, second one, the carrot will come at the end, because that's the whole purpose. The carrot will come at the end, and it will come at the end. Now let's look at the pattern. Over here, the first one could be any one of the 4. The first two could be any one of the four. The first three could be any one of the four. The first four could be any one of the four. That's the working that we do. The answer for the first part is 3 over 7. Leave it as it is. 3 ones are 3 twos are, and 3 fours are 12. So this is 2 over 7. I'm writing an equal sign more. Why? There is a reason for this. 4 and 3 is 12. 12 divided by 6. 4 into 3 is 12. 12 divided by 6 is 2. 2 threes are 6. So this is 6 over 35. This one is 4, 4 cancel. 3, 2 and 6 cancel. That is 3 over 35. And this one is 3 over 3. So let me just correct it. This is 3 over here. 3 over 3 is 1. 4, 4 cancel. 2, 3 and 6 cancel. This is 1 over 35. Now what do you observe? That mostly it's written with a denominator of 35. So can I write 2 over 7 as multiply by 5 in the numerator denominator, that is 10 over 35, and that's my habit of doing it. And over here 7 5s are 35, 3 5s are 15. So everything is ready. Now let me double check. What will I double check? 15 and 10, 25. 25 plus 6 is 31. 31 plus 3 is 34, plus 1 35. Everything is taken care of. So now the table that they are looking for is something like this. So let me just draw the table somewhere over here. This is the table that they are looking for. And this is X corresponding probability. This is 1 and 2 and 3 and 4 and 5. 15, 10, 6, 15 and 10 and 6 and 3 and 1. So everything is taken care of. So this is 35, 35, 35, 35, 35. That's the table. If I can copy it and let me take it to the other page, because I need to paste it. Why it doesn't paste? So now this is like this. This is X corresponding probability 1, 2, 3, 4, 5. And this is 15, 10, 6, 3, 1. 15, 10, 6, 3 and 1 divided by 35 and so on. And now it's asking us to calculate variance. For variance, we need to calculate expectation of X. So expectation of X, that is sigma Px. Expectation of X square, that is sigma Px square. So therefore for the first one, 1 into 15, 2 into 10, 3 into 6, 4 into 3 and 5 into 1. So let me push it to the left. And the whole thing added together divided by the denominator, which is how much? 35. That is the working for the expectation. And similarly for expectation of X square, let me take it down. So therefore this is make a column for X square. This is 1, 4, 9, 16, 25. So this is another column for X square. So therefore 1 into 15. So let me write it. This is 1 into 15 and 4 into 10 and 9 into 6 and 16 into 3 and 25 into 1. Everything divided by 35. So that is expectation of X square. Therefore variance of X is expectation of X square minus square of expectation of X. So the final answer is coming out to be 6 over 5 or 1.2. That's the very final answer. Now let's look at the examiner report for a second. This is June 2021. This is May-June 2021, the first variant of S1. And here is the exam report. Key message. I'm always interested in this. Most of the other thing I've already explained. Candidates should ensure that they communicate clearly, showing the necessary steps required to support the answer, particularly when they are required to explain a given numerical value. Where diagrams are required, it should be clearly and accurately drawn and appropriately labeled. Candidates should state only non-exact answers correct to 3 significant figures. That means if the answer is exact and if it's to 5 decimal places, write it as it is. Exact answers should be stated exactly. For example, is a fraction or a third. To justify a final answer correct to 3 significant figures, candidates should use values correct to at least 4 significant figures throughout the working. There is no requirement for fractions to be converted to decimals, so they are very, very happy for fractions, and this can often lead to a lack of accuracy. Which questions need this thing? Now this thing is question number 2 was that multiply by 500. That was about the expected number. People forget this. It has to be an integer. What else is there? What else is there? This thing, the probability one. A substantial number of incomplete solutions were seen to be this part of the questions, and the candidates often not providing a probability. Those who arrange the 6 letters then multiplied by the number of ways of placing A and D in non-adjacent places were often successful. So this is the space method that they have used, and we have used both the method, not together. This approach was least often seen. However, a better responses correctly used a denominator of 3 factorial to deal with the repetition of ease. The approach was less often seen. However, those that choose it were quite successful. The method most employed was to subtract the arrangement. So most people did the subtraction of arrangement with A and D together for the total number of arrangements. What else is there? And then this one is question number 4. Question number 5, this is that frequency thing. When candidates calculated frequency density, they were often able to access most of the remaining marks. Many others simply plotted frequency and time, few cumulative frequency. Good solutions stated that the frequency densities before drawing the graph. That is common sense. Candidates should be well advised to adopt the approach to assess with plotting accuracy. The data allowed simple scales to be used on each axis, and we should also label the axis. And it says continuity correction. Why would you do continuity correction in this one? The use of a ruler is essential to ensure that candidates can draw graphs to the appropriate degree of accuracy. Axes should be labeled carefully, including appropriate value of units for the variable. We will just do it in a short while. And this is all good. Question number 6 is binomial distribution. That is perfect. And clear calculations and continuity correction and everything, justification was there. This one was that Sharma question. Good solutions demonstrated an understanding that the situation was the one where tins could not be replaced. Once opened, requirement to justify the calculation. Weaker responses selected the tins from 7 each time. That's wrong. Table was present in most candidates' responses. Stronger responses appropriately identified the correct outcomes. Weaker responses included 0, 6, 7, with some omitting 4 and 5. The weakest solution tabulated the number of tens. The best solution included calculated. Many candidates required that the probability of 1 tin was this much. Those who use decimals instead of fractions were far less likely to obtain a sum of 1. So better advised to work in fractions. That I always emphasize in my class. Many candidates did not attempt this part of the question. Good solutions were characterized by the inclusion of a table. I mean, that was very easy. Who would not do this? So that finishes this particular paper, S1, November 2021, variant 51. Stay tuned for more.